Students, have you ever thought how plants absorb water from the surrounding? What is the mechanism by which plants take up water from the surrounding? Primarily, there are three phenomena by which plant does this. They are imbibition, diffusion, and osmosis. Now, what is imbibition? Imbibition is a phenomenon where living or dead structures, they absorb water by a process where the water molecules move into the system through hydrophilic surfaces. That means, like for example, the cell membrane which draws water in and thus swells up the structure. Okay? And therefore, it is through surface tension that the water moves in and swells up the structure. Imbibition is commonly seen in seeds, when we soak seeds. Like for example, I have taken a few dried gram seeds and soaked it in water, like this. Now, once we soak the gram seeds in water, can you see they have swollen up? This swelling up is due to the absorption of water from the surrounding and through the hydrophilic surfaces of the seeds, and they swell up. The pressure of the imbibition or the water inside, imbibed water inside, allows the seed coat to rupture and therefore facilitates the process of germination. So imbibition is a very common example by which water moves into the dry seeds and help them to germinate. Another common example of imbibition is especially during the rainy season, when we see our windows or our door panels, they get jammed. Why? Because they are made of wood, and this wood is porous in structure and they absorb moisture from the atmosphere and they swell up. When they swell up, it is difficult to close them or shut them down. This is also an example of imbibition. So, imbibition is a process or a phenomenon by which water moves into the system through hydrophilic surfaces by the process of surface tension and therefore swells up the structure. Another mechanism by which water is absorbed into the plants is diffusion. Diffusion, again, is a phenomenon which occurs when two different solutions of different concentration are in direct contact with each other, and the molecules move always from their region of higher concentration to their region of lower concentration until and unless the homogeneous mixture is formed. Now suppose we have taken in this tumbler water, plain water, and we will just add a pinch of potassium permanganate in it, and let's see what happens. Just watch. I've just added a pinch of potassium permanganate in it. Can you see the potassium permanganate granules start mixing in the water? Isn't it spectacular? And this continuous movement of the molecules from potassium permanganate at the bottom to the water, at the same time the water molecules are also intermingling with them. How long will this continue? Until and unless a homogeneous mixture is formed. That is, suppose I take and I stir up this solution. Once I stir up this solution, can you see the color becomes uniformly distributed all over. That means diffusion has already taken place. Okay, so diffusion we have to keep in mind. Diffusion always occurs from the molecules of both the solute and the solvent migrates from their region of higher concentration to their region of lower concentration until and unless a homogeneous mixture is formed. Okay. Another point to be noted is diffusion can occur in any medium. That is, it can be, the two solutions can be of solutions of liquid, both liquid solution, or solid liquid, as we have just done, granules of potassium permanganate moving into water. So that's a solid liquid solution. It can also occur between gases very easily. Gases can also diffuse in between each other when there is a mixture of gases, and will form a uniform or a homogeneously distributed molecules in the mixture. The third type of phenomenon, or the way by which water moves into the plant systems, is osmosis. A very, very important phenomenon which occurs in plants. Now, osmosis also occurs when there are two solutions of different concentration but separated by a semi-permeable membrane. When this occurs, it's only the solvent molecules which migrate from their region of higher concentration to their region of lower concentration through the semi-permeable membrane. Okay, solute molecules are restricted in the process of osmosis. It's only the solvent molecules which migrate from their region of higher concentration to their region of lower concentration. Like for example, I have taken, just observe here, these are Finally, the most important phenomenon which occurs in plants, which allows water to move into the plants, is osmosis. Osmosis is a phenomenon where two solutions of different concentration are separated by a semi-permeable membrane. Then the solvent molecules only migrate from their region of higher concentration to their region of lower concentration through the semi-permeable membrane. Now, for example, just see, these are some raisins. I have taken these raisins in water and soaked them for some time. Can you see, the raisins have become nice plump structures. Why? Because water has moved into, from the surrounding, water has moved into the raisins. Why did water move in this direction? Because raisin has concentrated sugar solution in it, and from the surrounding water, this water is of lower concentration. So water molecules migrate through the raisin, the outer membrane of the raisin, into the raisin, swelling it into a nice plump structures like this. This is an example of osmosis. Another thing we see, now these are some freshly cut cucumber pieces. They are tight and taut. But these same thing I've taken here and I've added a bit of salt in it. When I add salt in it, can you see, water has naturally come out of these, and these have become soft. These have become soft. They are not as fresh and crisp as these slices. Why? Because water, when we sprinkle salt over them, the salt outside becomes concentrated compared to the water inside the cucumber. So, the water from the cucumber moves out and makes the cucumbers soft. And the water has come out to the surface. So, this is an example of endosmosis because surrounding water moves into the raisins, making them plump. So, this is an example of endosmosis because the raisins have concentrated sugar solution in them, and therefore surrounding water, which is of less concentration, moves into the raisins and swell them up. This is an example of endosmosis. However, this one, slices of cucumber, when we sprinkle salt on them, the salt itself functions as a hypertonic medium and therefore draws the water out of the cucumber slices, making them soft, though this is an example of exosmosis. We can demonstrate this very well here. We take a container. These red dots represent water molecules and the green balls represent the solute molecules. So solvent molecule in this part, can you see, is more compared to here. Therefore, the solvent molecules will migrate from a region of their higher concentration to their lower concentration. So in this direction, the water will move. So this is an example of osmosis. Migration from here to here. As the semi-permeable membrane pores are very small, they restrict the solute molecules to move across. So it's only the migration of the solvent molecules in this direction.